Dear friends, architects, engineers and consultant engineers and my student of MEP classes. Welcome back to VK Jain Sir ki MEP classes. Uh, in this particular electrical module, I have divided it into 4 different parts. This is first of them. That is integrated in interior electrical services, difference between AC and DC and single and 3 phases. Okay, friends, in physics classes or starting electrical classes, we have been talking of DC voltage, of which the time graph is a straight line. A straight line. This is time versus voltage. It is a straight line. But in case of AC, it alternates. That's why the generator which produces this type of waveform is known as alternator. Now here the voltage goes to negative side and then positive side and it alternates. And from here to here it completes one cycle. So if we say 50 cycles, that means 50 such cycles will be repeated during course of this application of AC voltage. In case of DC, you have a DC supply through battery, some battery, and that battery has a positive pole and negative, and the current flows in this direction. This is the load, R is the resistance or load, and direction of current flow is like this, that is clockwise. In case of AC, this is alternator. This is a generator or turbo generator or such item, and in this the current flows one cycle like this and another cycle like this, and the R represents resistance, or actually it is impedance, Z. Friends, once again discussing between single phase and 3 phase. The definition of single phase is one alternating voltage cycle. In 3 phase, 3 AC voltage, and if it is balanced, they are 120 degree apart. Number of wire in single phase, they can be 2, positive and neutral. In case of AC supply, it is 3 to 4, 3 phases plus 1 neutral. Power supply. In single phase is meant for lower power demands, whereas in 3 phase there is no limitation. It is continuous power delivered. Efficiency in case of single phase is lower and 3 phase it is higher. This single phase voltage is 230 volt, which is just root 3 of 415 volts. If you divide 415 volt by root 3, that is 1.73, you will get 230. Application. Single phase is deployed in homes and for a small load. And in Delhi, you can go up to 30 kilowatt. a single phase supply for one consumer. In case of three phase, industries, large buildings, and HVAC application fine require three phase. Let me tell you frankly, any load above 5 kVA is normally supplied in three phase by electricity board throughout the India. Friends, once again slide telling difference between AC and DC power supply. The waveform in case of AC is sinusoidal, and in case of DC it is a straight line. By waveform we means time versus voltage. Frequency, single phase 50 Hz or 60 Hz. In case of DC there is no frequency. Voltage variation continuously varies with time. Here in case of DC it is constant. Transmission, easy and economical for long distances, not suitable without conversion. Generation, produced in power plants using alternators or generators. DC, produced by battery solar cells. Examples, household electricity. In case of DC, it is limited to batteries and mobile chargers. We are comparing characteristic feature of AC and DC both. First feature, direction. It periodically changes, and in case of DC, one single direction. Frequency, 50 or 60, 50 in India and British ruled countries, otherwise 60 all world over, including America, Dubai, etc. In case of direct current, there is no meaning of frequency. Voltage change, EG through transformer. Voltage current direction, direct current, very difficult. Transmission, long distances. This is DC is for short distance. The only characteristic feature which is vulnerable is that AC electric supply cannot be stored, whereas DC can be stored but in small amounts. Example devices, AC are used everywhere in household, offices, for deriving motors, pumps. In case of battery, direct current, it is limited to batteries and electronic items. Friends, this particular chart shows application of AC and DC. AC waveform is sinusoidal. In case of DC, the voltage versus time curve is a direct line. Here it is alternating. Second, AC is widely used for power grids. DC is deployed for very high voltages, 1100 kV, and that type of application is known as HVDC for long distance. That means from powerhouse up to the first zonal grid, nearest zonal grid. Application wise, you will find it everywhere, and both the things everywhere. But batteries and solar EV charging systems are currently evolved Friends, the content of this slide have been previously discussed. The one feature of is that single phase is cheaper to install for low power needs. Three phase is more economical for higher power demands due to better conductor. And uh, normally electricity company are giving uh, residential single phase AC up to 30 kVA, and in case of they are asking consumer to take uh, three phase power supply if their power demand is beyond 125 kVA. Friends, just study it for a minute. This will make your concept about single to three phase. This particular diagram shows three loads connected in star formation. So if you apply voltage of 415 volts while utilizing single phase, you have to go to 240 volts. Whereas if you are applying the load between two phases, R and Y, or Y and R, then the voltage is 415 volts. Power consumption can be taken like this. The formula is root 3. Root 3 is 1.73. Voltage line, I line, and cos phi. Cos phi is the power factor between the load, load utilization. So this formula applies either for single phase or three phase application. Friends, here also the previous formula is applicable, but here the loads are connected in delta, so you will not get a neutral point. In the previous slide, it was possible to get a neutral point. So that is the difference between delta type and star type. Normally the transmission happens in delta to delta. Friends, once again we will discuss difference between AC and DC. Both AC and DC describe type of current flow in a circuit. In direct current, the electric charge current only flows in one direction. The electric charge in alternating current, on the other hand, changes the direction periodically, once in 100 times of a second. Most of the digital electronics that you build will use DC. AC, that is alternating current, electricity. AC electricity is what most household electrical appliances require to operate. The other type of electricity, DC current, is what solar panels and batteries produce. DC electricity is converted to usable AC electricity through a device called inverter. So we use inverter in every middle class residences. AC current is distinguished from DC current primarily by the fact that its direction switches back and forth rapidly, whereas DC is unidirectional. Without getting into the technical details as to why this property makes AC electricity more suitable for long distance transmissions. Now I like to narrate. You can have an inverter, but inverter is not UPS. So in case if you have not provided UPS to your individual computer equipment, then inverter will not help you. Friends, this diagram makes the concept more clear. Say in case we have a three-phase power supply, uh, these three phases star connected, this is star connected, is supplying R, Y and V, three phases symbolically, and between R, Y or blue, you take phase wire, single phase wire, and you take neutral from here, this black. So if you have taken three phase, in case of motors, no neutral is necessary, but in case of uh, power sockets of 5 or 15 ampere or 6 or 16 ampere, you take one phase and one neutral here. So you have to learn the concept of line and phase. In case of motor, neutral is not necessary, but in other single phase loads, utilize like electrical bulb or sockets, power socket or 5 ampere or 6 ampere or 15 or 16 ampere sockets, they utilize uh, this neutral wire also. In case of single illumination circuits, also same thing. Friends, this diagram shows electric supply on coming from LT panel of substation. You have a riser system, and this switchboards are rising connected through this riser bus bar. Say if it is red phase, it is connected like this, and ultimately you are using 12-way or 4-way TPL or SPN distribution board. Friends, thanks for peacefully and meaningfully watching my video. Thanks once again from Engineer VK.